see that you work. I don't know how you work. There you go. All right, guys. You'll notice there's a lot of emphasis, which I love the students who don't come and they get angry at me that they're not passing. I will live for that shit. So you're doing good things. You're at least here. It's good. Don't you worry about them. You worry about yourself. So that's the last one we did there, was using the properties of logs to condense these guys. And then we can simplify if possible. So you need to get used to these properties. Okay. This is section 12.4. 12.5 was really just the main thing with 12.5 was the different bases, like if you see a log by itself, what does that mean? You just see log x. What base is that? 10. Just like when I see this.
Do you have an extra 12.4?
Maybe. The one I'm writing on? I might have some more. Wait, let me find out. Just like when I see this, there's no number here, but I know it's a square root. This is the most used root. Log base 10 is the most used log, so we just don't write the 10 to save some time. Right? Math people are really weird like that, but oh well. We just deal with it. What about the other base? What's the other special base that we talked about? Anybody remember? There was another special base. Yeah. E. I like that. So in the back. E. So base E. Where'd base E come from? Oh, that's the one that's all written on. Oh yeah, all right. So we talked a little bit about some places where it came from. You don't have to know those places. I'm not going to ask you a test question like, where did E come from? The reason I want to give you a little background about where it came from was because you need to understand why we gave it a letter. We gave pi a letter. We did, because pi is freaky, right? No matter how big or small a circle is, a divided circumference by a diameter, I get the same number of civilizations got freaked out, thought it must be from the gods, tried to estimate it. Now we can have computers take it out to stupid numbers of places, but it's just pi. E is sort of similar in that it comes up in some weird, unexpected places. So we had to give it a symbol to kind of wrap our brains around it. All right. So when I see what log is related to base E? What logarithm is related to base E? No, that's the common log. I don't write log base E. What do I write? So I don't write log base E. Ooh, here we go. Sean needed one of these, right? You? Yes. Anybody else need one of these sheets I got up here? Yes, I heard it over there. So we don't write log base E. That's the second time I've written that for you, and it really is painful. We write ln x. That's the natural log. That's what natural log means. It means base E. I like it. Freaky. Now, let me run around some more. We ended up talking about change of base formula, so I've got that at the top of this handout here. passing out papers. So to put it at the very top here, the idea of the change of base. The only reason that we use log base 10 or ln in general is because those are the ones that are on the face of my calculator. On the TI graphics calculator, you can find log and ln. So how would you do like this guy right here? How would you rewrite this? Oh, what? Wait. You guys see how it's right here? It's log base 0.1 of 3. So this is down here. This is down. So what goes on the bottom? The base goes on the bottom. Beautiful, right? That's awesome. So log of 0.1, and what goes on the top is the other one. Log 3. So if you do in your calculator log 3 divided by log 0.1, or you could do natural log of 3 divided by natural log of 0.1. Those will end up being the exact same answer. We actually proved this formula last time. If you don't remember it, I've got video evidence that you can access. I don't know, anybody get that? Anybody get that in their calculator? So let's see, log 3, close parentheses, so evil. It's like Microsoft Word trying to freaking guess what I want. Stop it. Divided by log 0.1. I get this. If I do natural log of 3 divided by natural log of 0.1, I get the same damn thing. I do like summary actually, but we don't have to go crazy. What the hell does that mean? What's that number mean? What's that number? Can somebody tell me anything about that number? Don't tell me it's negative. Don't tell me it's smaller than 1,000,000. Tell me something about, related to where it came from, where the problem started.
Okay, another number. Yeah.
What does log base 0.1 of 3 mean? What's a log always equal? A log is always a exponent or a power. Let me say it, come on, stay with me now. The answer to a log is always a power. In fact, that's how you figure out logarithms by yourself without a calculator, is you think, what do I need to raise the base to make it become the inside, right? A logarithm is always a power. So this is the power. Why is this a power? Because it's the answer to a log question. The power that what needs to become what? So watch. Let me here. At this point, you've got to be able to do this question I'm about to write down. If you cannot, you are behind. Log base 7 of 49 is 2. This is not division. We already have a division symbol. Well, we go, let's make division log. No. Let's multiplication leaf. No. Log base 7 of 49 is 2. What does 2 do? What's 2 mean in this case? 2 is the power that 7 needs to become 49. Okay, let's try this one again. I know they're ugly numbers. Negative 0.47 blah, blah, blah is the power that 0.1 needs to become 3. So watch what happens when I raise 0.1 to the that things. Answer is the thing. Answer is the last thing that was on the screen. 0.1 to the that thing. It's frickin' 3. Of course it is. Because that's what we figured out. Do the lottery. Wow. So you gotta, I'm not always going to ask you, tell me what that number means. But that's the problem people have with math, is you got to realize this number that I get has meaning. Even if it's not a word problem, it has meaning. Okay. You guys do this one. And negative 0.4771 for that one. Let me write it in. You guys try number 2. So I'm going to start doing these the way I would normally do these. Which way do you think math people like to do it, with a log or with an ln? Why ln? Because there's one less letter to write. Yes. So we're lazy or we're frugal with our time. So this would be ln of what over ln of what? So I do ln 10 divided by ln 4. I get 1.66, blah, blah, blah. Can somebody tell me why that makes sense? What is this supposed to be? The answer is supposed to be the what, that what? Yeah, the power of the 4 needs to become 10. 4 squared is whole square, 16. 4 squared is 16, so the answer to this should be less than 2. 4 needs a 2 to become 16, so 4 needs less to become 10. We got freaking 1.661, roughly. I mean, that's nice. It's about 1.661. So if you do 4 to the 1.661, will it be 10? Not quite. Right? Why is it not quite? Because I'm rounded. That's why. But yeah, that's pretty damn close for government work. Okay. All right. So that's the change of base form. It's a very interesting little formula. Semi-useful. To be completely honest, where is that stupid thing? Somewhere there's a log, a general log base. I don't know where the heck it went. There you go, log base. Math teachers. Technology killing. All right, now. So I don't know if you remember the whole discussion. Oh, yes.
Makes me think about, like a scientist getting it exactly right, but it's not exactly, but it's pretty close.
I'm glad you said that. Real quick. This is interesting. If I say I want the exact answer, which one of these is that? That one. Look at that desk. This is the exact answer. And this is the approximate, just like Sean said. Everybody says that's the exact answer because they're like, oh, it's decimals. I said, no, but we rounded this damn thing. This is the exact answer. But this answer is unsatisfactory, right? It's like somebody said, how much you get paid an hour? A natural log of 17 divided by natural log of $3. Can you round that for me? Right? I mean, so this is the exact answer. This is the more practical answer. All right. Okay. So that's what the difference is between exact and approximate. Exact means you haven't turned it into decimals yet, to be honest, because you always have to round. Yes?
So when you have like a question like that, like on the test or the quiz, you're going to ask us find the exact answer or find the approximate?
Yes. I love it. Real quick, just to really, really, really make sure you guys buy into this this formula. Where did I put you? I brought paper and then okay. Real quick. What should log base 2 of 8 be? 3. What would it look like if I used the change of base formula? ln 8 over ln 2. And if you do ln 8 divided by ln 2, I get 3. Okay, I like it, right? I mean, of course it should work even on stuff that we should be able to do in our head. I should never have shown you that, because now you can just do that. Oh, well, shoot. Should probably tell you that. We're going to have no calculators allowed on something here. Yay. Okay, so, getting back into what I was about to get into. Stay with me now. When we first started talking about inverse functions, why are they important? Whenever I learn a function, why should I learn its inverse at the same time? What is it that I can't do unless I know the inverse? What are inverses primarily used for? I know you guys are all like, I've been graphing them, I've been finding them, but we've been using it ever since you started algebra. You've been using inverse functions. When you solve an equation, what's the primary thing you keep doing every step is you do the opposite. If it's x plus 2 equals 7, I'm going to subtract 2. You apply the inverse function. If we said that when we first taught that to you, you'd run away, so we don't say that until you get here. You guys with me? So inverse functions can be as simple as, if it's addition, the inverse is subtraction of that thing, right? But of course they can get a lot more complicated. Depends on how ugly the function itself is. So when we go to solve exponential logarithmic equations, I want to show you 2 ways to do this first one. Now normally, what do we do when we have an exponential equation? We try to make the bases the same. We've seen that a few times already. We saw that, I think, on that last handout we did. Try to make the bases the same and then go from there. Then you can make the exponents the same. We'll have an example here in a minute. Well, how would I do this? Can you make the bases the same? Can you make 19 based on 2 easily? In fact, this is basically the question. 19 is 2 to the what? So, no, if it was 16, I can make it based on 2 easy. So now I want you to see something. Can you guys rewrite this? I'm going to show you one way to do this. I'm going to do this way first because it's the way that we're going to do less often. And then I'm going to focus on the other way. But I want you to see this thing we just did in action. Can you rewrite this in logarithmic form? Just try to rewrite that in logarithmic form. That's a skill you have to have, period. Can you rewrite it in the other form? Oh shit. So what I mean is rewrite this log base something of something equals something. And we'll rewrite it in that form. I love you guys. At least you're here physically. Some of you guys are on your phone, of course. Some of you guys are reading lotion bottles. I don't know. Whatever gets you through. As long as you're able to do this. Yeah, what's the base here? 2?
19.
Good. The output becomes the input because the inverse function equals x. But then, all right, and like most of us don't know where our log-based thing was until I showed you earlier, but oh well. How would I rewrite this using the change of base formula? That would be what?
Log base.
All right, so one way to do it is do log, what's on the top? 19 over log 2, or natural log 19 over natural log of 2, right? Yeah, I like it. Now, we do that problem again. But this is the way I want to see this more often done. If you do it this way, I'm actually not going to tear into you. I mean, you're going to be fine. But I want you to get used to this second way of doing this because it's more related to how we solve equations in general. So the only thing that has the power to bring down the exponent. So if I have like a square root equation, my x is inside of a square root. What am I going to do eventually to my equation to get it out of there? How do I free it out of a square root? Square both sides. If it was in a square, I would square root both sides, right? If it was underneath, it was 1 over x. I'm going to multiply. I'm going to do the inverse all the time, right? I do what's going to make it come out of where it's stuck. So then I can get it by itself. Does that make sense? That's a very general way of saying how we solve equations. The only thing that can make an exponent unstuck is a logarithm. So if I take ln of both sides, now be careful, you do not write this like this, ln. I think I've told you this before. This doesn't make any damn sense. This can't be 19 times ln. It's like saying 4 times square root symbol. It doesn't make any sense. It's got to be ln of equals ln of. Now what can I do on this side? What did I take an ln for? So I could do what with the x? What's the property that I can do? I can take this down. Logs are the only function that can do that. And now how do I get x by itself? How do I get x by itself?
Divide by x.
Yeah, this is x times a number equals a number. So how do I get x by itself? I divide by the stupid number I don't want anymore. I know it looks weird. I know it's ln2. It's just a number though, right? ln2 is a number. Is it a pretty number? No. Poor little number. So x equals, now look, I got the same answer, of course. Mathematically, it's the same thing. Anybody got that answer? The approximate? 4.2479, so it's 4.248, roughly. Which makes sense, of course, because 2 to the 4th is 16, so 2 to a little more than 4 is a little more than 16. Some of you guys look at me like you're plotting my death, but I'll try to keep going. You guys do this one. Don't overthink it. Try to do the first step and then I'll come in there. Well, that's why it's lower. What happens after this step here? You take ln of both sides, because my variable term is stuck up here. I move this whole thing down. Now here's where you guys are going to have some trouble. You do not want to put approximations here and start working with the decimals because you're not going to get anywhere near the right answer. If you round early, it's going to go to shit later. You don't want to round it all till the end. So you have to maintain this ln business. What's a good next step? Do I want to distribute this thing? Personally, I don't. What can I do instead? Divide it by ln and 11. ln. 3x minus 4 equals this number. This is gross, but it's just a number. It's just, 2.6 or something. It's just a number. How do I get x by itself? Add 4. So you get 3x equals, give me a paper. 3x equals natural log of 152 over natural log of 11 plus 4. And then I divide by 3. So we get x equals ln of 152 divided by ln of 11 plus 4 all over 3. Yummy. Let me just write this and see if anybody is with me here. Now that's fine. If you stop there, it's fine. You can actually write this like this. That divided by 3 is this. That divided by 3 is this. Doesn't matter. Either way, I'll take it, but you should know how to go from here to here. 3's on the bottom, so 3's on the bottom, 3's on the bottom. Whoop-de-doo. And now see if you have a calculator, see if you can throw it in there, get an approximate answer. Let me catch up. Anybody got the answer? The approximate answer?
2.03171.
Yeah, 2.032. Roughly 2.0317. Yeah. 2.0317. Roughly. So that's the exact answer, one of these two. And this is an approximation. Let me show you a cool way to check this. You ready? Notice what I did real quick. I did ln152 divided by 3 divided by ln11 because it's being divided by both of these things. Alright. Watch this. I can store this in x. I think I've shown you that before. Store it in x. Right there. Then you can basically just type in the problem as it looks. So what was the problem? The problem was 11 to the 3x by... Okay, so 11, gather on. 11 to the 3x minus 4. And hit equals, right? Hit enter, and let's see. 152. Yay! So if you store it in x, you can just write the one side exactly the way it looks. Because now x has the answer in it. And you're actually checking it. Does it come out to be what it's supposed to be? Yes, it comes out to be 152. Yay! So here, you guys try these two on the back. You should notice there's a quick way to do one of those two. We've done a lot of problems like number 2. Before we talked about taking logs of both sides or anything. Number 2 should be the one that's real quick. here. If I take ln of both sides, I can then take that x minus 3 out front. But for some reason, I always have somebody take that x minus 3 without even taking ln, so they just take it down. The only reason I'm allowed to take that down is because I put an ln on both sides. That's the one that's got that property. Now what do I do from here? Your x minus 3 equals this number. And then the last thing to do is add 3. So you get x equals ln 15 over ln 7 plus 3. And then if you throw that in the calculator, you should get 4 point something or other. 4.3916.
Mine rounded up.
Is what was the next number?
Yeah.
3916 something. 62. So then don't. I like it. This one, what's a quick way to do this one? Why is there a quick way to do this one? How can you rewrite 36? Yeah, 6 to the x plus 3 equals 6 squared. So then what's got to be true about x plus 3? X plus 3 has to be 2. That's the only way that equation can be true. Is if that power equals that power. So x is x of use. Negative 1. All right. I'll do this one. What's up? Your cheeks. Bless you.
Thank you.
Now what's a little bit different that happens here? A little tiny bit different. If I take ln of both sides, what happens right off the bat? What happens on this side? ln and e cancel. Why? Because ln is the inverse of e. So this side just becomes 0.05t. That's nice. And the other side, I got natural log of 150. Oh well. And then, of course, really just one more step to solve it. Divide by 0.05. Divide by 0.05. So I get t is ln of 150 divided by 0.05. That's the exact answer. And then if you do that in the calculator, what do you guys get? Why?
We canceled the
ln e, yes. Because those are inverses of each other. Yeah. This is approximately what? 100.2127 I got. So you use, yes?
On the test, how far for the answers, how far do you want us?
I'll say, if there's a specific number, I'll say. Yeah. In general, I don't say 3 places is a good amount. But I'll say on there how far to go. So real quick, that could be, well, if it was a negative power, that would mean radioactive decay. So there's a certain level of radiation that we can actually live with, because we do currently live with that radiation. If you ever go on a plane, you guys know that if you're on a plane, you're getting more radiation exposure than you would on the ground. Do you guys know that? So that's something that actually, if you work in the airline industry, you have to be careful about. You don't have to wear lead protection, but still, they have to be careful about how many hours they log. So if there was a nuclear accident, like Chernobyl, or what we almost had at 3 Mile Island, and I wanted to know how long until I could actually go back there and live there, we could set the equation that talks about how quickly does it decrease in radioactivity, and say it equals some number. Equals some number of some amount of radioactivity. I can solve for t. That would be the time it takes until that reaches that level. So I can figure out how long until we can go plant some stuff, and the plants don't come all weird. Tomatoes the size of houses.
Yeah, I remember when that happened in the Soviet Union a long time ago. And I still think that they're waiting for that half-life to happen.
Oh hell yeah! It's
Talking about that, right?
it's like thousands of years. I can't remember the exact amount of time. But yeah, that's not going to be That's not going to be usable. They made one horror movie out of it. Let's hope that's the last one. All right, guys. One last thing. I'll let you guys out of here. We've already done a problem like this one. How do I solve this equation? How do I solve that? Yeah, rewrite it. 4 to the third is x. So x is 4 to the third. What's 4 to the third? That's fantastic. 64. So what would be the first thing I have to do in number 2? I wouldn't do that. Now how do I rewrite that? What's the base? Careful. This 8 ln, this is log, so what's the base? 10. So 10 to the negative 2 is x. What is 10 to the negative 2? 1 over 100, I love it. Marco comes roaring back. So number 3 is really the same thing. Try to do the first step of number 3. The idea of how to rewrite a logarithm into an exponential is by itself a very, very basic thing. So you have to have that part down. And I put that up here for you again. So how do I rewrite this? 3 to the 4th power is 6 minus 5x. What is 3 to the 4th power? 81. So a couple steps and I'm back into chapter 2, really, of this book, back into Math 90 at the beginning of the class. Saw that little sucker there? So subtract 6. You get 75 equals negative 5x. Divide by negative 5. The x is negative 15. I like it. See, rewriting a logarithm in exponential gets rid of the log. And you have an equation with no log in it. Sounds better? All right. That's enough for now. I'll see if you guys in the lab for the quiz. Okay.
So this one, for example, here. So I will draw the first one. This is the base for the 12.
Yep. And then you pick a point.
Like this, I will
Sure.
shift to the 3.
Up 3.
Okay.
Over.
Then
Yep,
shift
over.
it minus 2. Shift it
Over
sorry.
2, yep.
Yeah. So the base will be start here from this.
Yeah, the asymptote's going to go up 3.
Oh, okay.
Yeah, moving it left and right doesn't do anything. It's infinitely long. But it, up and down really moves where it is.
Okay.
Yeah.
Then each point, this is the point that I shifted to
Yeah,
the 3.
so, yeah.
Then I will be shifted right to the 2.
Yes.
Like so for this it will be here. For this it will be here. For example.
Yeah, so every point here, up 3 over 2. Up 3 over 2, yeah. And that becomes, and it just moves it up and over. The whole thing moves. I love it.
Okay.
And finding the asymptote's good because that gives it the floor.
Yeah.
Yeah.
Thank you.
Sure.